to today's Cosmology segment. It should be quite interesting, and so we're streaming it live to Twitch. This is a portion of the daily space weather video, and if you want to see the whole content, become a patron at patreon.com/smashamash. First, double quasars. Hubble has spotted some double quasars. Now, these are located about 10 billion light years away, and double quasars are fairly rare in that quasars are galactic cores, and they're a special kind of galactic cores, some of the most active galactic nuclei, maybe second only to blazars. The poloidal jets of these galactic cores are oriented directly towards you, which is why they look so bright, and about 1 out of every 1,000 quasars are doubles. It's like looking for a needle in a haystack, and Hubble has found a couple of them in let me go back up here, in J0749 plus 2255 and J0841 plus 4825. So those are a couple examples of double quasars. And these are interesting objects to say the least. Those two that we just showed you photos of are only about 10,000 light years apart. And to put that in context, the Sun is about 26,000 light years from the Milky Way's galactic core. This article's on phys.org's Astronomy and Space section. Go have yourself a read if you want to read about double quasars. I thought it was interesting. What about you? And by the way, here's one of the double quasars you can find. This galaxy is actually NGC 6240. We've got this incredible high-resolution image here. And let's zoom in on the core of this galaxy. You can actually see the two bright spots in there, one of the many already discovered double quasars. Fantastic view of that. Again, it's galaxy NGC 6240, the new general catalog, entry number 6240. And it looks like a merging galaxy to me. What say you? How about a new gamma ray emission detected? It's from supernoval remnant G272.2-3.2, a catchy name. And this one is located at quite a great distance, folks. But in any case, we're going to show you some imagery of this area. Now, this is located pretty close to the galactic plane, so it's going to there's going to be some limited data on this one, but we'll show you some interesting stuff regardless. And yesterday we talked about pevitrons. This is a little bit lower energy state than pevitrons, but we're looking at giga-electron volts here. So 2 to 500 giga-electron volt energy band is quite high energy. This article also from phys.org in the Astronomy and Space section. It's supernoval remnant G272.2-3.2. So go have a read on that if you like. Gamma ray emissions noted from that. And here actually it is. So this is what we're looking at here is hydrogen alpha, folks. So this is the spectra of hydrogen gas, and you can see this massive gas cloud. That's the Milky Way galaxy. And this supernoval remnant is actually on the other side of that. So we're going to pull this down, and we're going to put up the 2 mass, which is infrared light. And we're going to zoom in on this supernoval remnant. And you can see there's not really a lot to see there. This is located at a great distance. And let me see here. I think this one shows up in UV. Maybe not. How about blue light? Maybe not. How about optical? Anyway, it's a very tough to see supernoval remnant. It's not particularly exciting looking. However, since it is emitting gamma rays, it is interesting. Now, there is also some interesting features here. It does look like there may be a jet involved with this one, but without continuing to look at basically a blank part of space here. We'll just continue on. To talk about talcum powder comets. So, that right there is a Chinese baby powder factory talc pulverization talcum powder boom. Turns out that some comets, namely Comet P2016 BA14 discovered by Pan-STARRS, is covered in talcum powder. Yeah, for real. It's a burnt-out comet. What are the chances, folks? It's a burnt-out comet covered with talcum powder. Now, Johnson & Johnson is trying to mine the surface of the comet in order to cheapen their talcum powder production operation. I'm just kidding, folks. They're not really trying to mine the comet. Anyway, the fact is, the question is whether comets are covered with talcum powder from the start or if it develops over time as they burn out. The result provides us a precious clue to study the evolution of comets, comments Dr. Takafumi Utsubo, the lead author of the research. We believe that further observations of the comet nuclei will enable us to learn more about the evolution of comets. It's a talcum powder comet, folks. What are the chances? And that's today's Cosmology segment. And don't forget to share our content on your social media if you enjoy it. Don't forget to follow us on YouTube if you're viewing elsewhere. I've been your host, Dan, a.k.a. smAsho. And again, that's today's Cosmology segment.